Welcome back. In this video, I want to cover the question of what is radioactivity to start our new topic. All of the important information, as usual, is here above my head. And automatically, you can see from that picture, there are three types of radioactivity we need to cover. So first of all, what is radioactivity? Basically, it's when you've got an unstable atom or an unstable nucleus, and that nucleus needs to become stable. It's basically unstable because it has too many neutrons. You already know that there's two types of particles inside a nucleus. There's protons, shown here in blue, and neutrons. Basically, if a nucleus has too many neutrons, it's unstable, and it can become stable by either spitting out this, we call it a particle, but it's made up of three mini particles, an alpha particle, which is made of two protons and two neutrons. That's one way it can try to become stable. The second way, a bit difficult to understand, but it can become stable by spitting out an electron. Now, you already know that you expect electrons to be orbiting the nucleus, but in this case, this beta particle, this electron, beta particle is an electron, is coming from inside the nucleus. And it comes from inside a nucleus because a neutron turns into a proton. So therefore, the nucleus gains positive charge, and it needs to get rid of the negative charge that was produced by that process. That negative charge is released as a beta particle. The third type of radioactivity that's released is called a gamma ray or gamma radiation. This is different because it's not a particle like the other two, it's pure energy. We've already seen gamma radiation as part of the electromagnetic spectrum, and you already know that it's the highest frequency waves that we saw with the smallest wavelength and with the most energy. So that's gamma radiation. Usually gamma radiation is released after the nucleus has already released alpha particle or a beta particle. All right, so let me start with a very short story. This handsome looking chap is Henri Becquerel. In the year 1896, he was working with some very strange types of rocks because he was working with the idea of fluorescence. Nobody understood at the time what fluorescence was. By accident, he left these very strange rocks in a drawer with a metal cross, and also inside the drawer was a photographic plate, an undeveloped photographic plate. Now, he didn't realize that the rocks he was using contained the radioactive atoms uranium. When he took the materials out of his drawer, this was what he found on the photographic plate. The photographic plate had been developed except for where the cross was in contact. So he realized that those rocks were giving off some type of energy, and the energy couldn't pass through the metal cross. He'd basically discovered, because it's uranium, he'd actually discovered alpha particles. Okay, let's get to the properties of these types of radiation. Okay, so those are the three types. We give them Greek letters of the alphabet: alpha, beta, gamma. We've already covered some of this information already. An alpha particle is fairly big on a relative scale of things. It's made up of two protons and two neutrons. Because it contains protons, it's got a positive charge, a double positive charge overall. They're slow-moving, large particles, so they're easily stopped. They can't actually get through a piece of paper, or through, if you were in a cotton shirt, they couldn't get through your cotton shirt. So therefore, you might think they're not very dangerous. But because they're big, they're very likely to come into contact or collide with other atoms. That could be, for example, particles as they move through the air. When they hit other particles, they ionize the other particles. Ionization in this case basically means hitting the other particle and knocking out an electron, turning that particle into an ion. The dangerous thing about that is if those particles are inside your body, specifically part of your DNA, alpha particles can cause very bad damage to your DNA. And if your DNA is damaged, that leads to the formation of tumours or cancers. So alpha particles, not dangerous by themselves, but if a source of alpha particles could get inside your body they could cause severe damage to your body by causing the formation of tumours. Next is beta particle. We've already said a beta particle is an electron that comes from a nucleus. Because it's an electron, it's therefore negatively charged. It's got a 1 minus charge. It's got more energy than alpha particles, so therefore it can pass through a piece of paper or something like that. But it can be stopped by a very thin piece of metal, for example, a piece of aluminium foil. Not as ionizing as alpha particles because they're so small and less likely to come into contact or bump into other atoms or other particles, but they're slightly ionizing. Then finally, we get to gamma rays. We've already said these are not particles, that's why we're referring to them as rays or radiation. They're electromagnetic waves. Maybe I shouldn't have put that. We shouldn't really say they're small because they're not particles. They have a high frequency, they're very high frequency electromagnetic waves. Because they're waves, they have no charge. Very, very difficult to stop in this case because they got so much energy. They're not ionizing because they don't really have the ability to knock electrons out of other atoms. But they're still very, very dangerous because they can cause very, very severe burns. You've possibly seen pictures of survivors of the Hiroshima or Nagasaki bombs with awful radiation burns, and those radiation burns are caused by gamma rays. Okay, so in summary, 3 types of radiation: alpha, beta, gamma. Alpha, large, slow-moving particles made up of 2 protons and 2 neutrons that can't pass through pieces of paper, for example, but can be very ionizing and therefore very dangerous. Beta particles, tiny, made of electrons, not as ionizing as an alpha particle, but they can pass through paper, but not through a thin piece of metal like aluminium foil. And finally, gamma, not particles, the electromagnetic radiation, contain loads of energy, so much so that they can pass easily through paper, aluminium. They're only stopped by very, very thick sheets of lead or very, very thick sheets of concrete, very, very dense materials that can absorb the energy. Okay, so I hope that made some sense. Obviously, send me comments if you want any more clarification on this stuff. Stay safe and hopefully see you soon. Okay, goodbye everybody.